Who are you?
I'm Staffan Laestadius. I'm a retired professor of industrial transformation at the Royal Institute of Technology here in Stockholm. And who are you?
My name is Naram-Sin Poli. I just finished my bachelor's in biology here at Stockholm University. The ThirdTask, what is it for you?
I think academia is a core institution for knowledge formation in society. And we do research, we do teach, and we should inform others of our results, not only via teaching by students, but also informing the whole society on the knowledge formation we do in the universities.
Obviously, we need to reduce our global emissions,
Yeah.
right? And a lot of these goals that we have are so far in the future, right? We're talking about 2045, we're talking about 2065, and so on. Doesn't this, I mean, it feels like a way for people to kind of just push the responsibility forward. What is a solution to that? What is a different way of thinking? Perhaps that could be more graspable, where we can hold people accountable. I cannot hold a politician accountable today in 45 years or 30 years, right?
Yeah. I think it is not a question of conspiracy theory here that people that are doing it will make decision makers now that they want to avoid the problem. But I think many think that it must be a slow process to transform, and therefore they tend to have long-term goals, imagining that they will build up the capacity or capability to transform during this period. But I think this is a wrong way of thinking. You must have short-term goals and targets. First of all, because now the crisis is here, even if you don't find it outside this room. The climate crisis is here. That means we must reduce our emissions annually with 7, 10 or 14% from now, not from 2030.
Do you think it's possible with today, with the 1.5 degrees?
It can be so that we have already passed the tipping point where we cannot avoid stepping over 1.5 centigrades. But maybe we have, say, 5 years or something on the present level of emissions. And if we have reducing our emissions, we could probably have the whole decade here to keep under 1.5 centigrades. Then there is no more space for emissions. That means no more emissions for our children or our grandchildren or those of us who live after that. This is a very tough situation.
I mean, you know, the Paris Agreement and all these things, they become a little somehow useless for me. You know, I feel like, you know, it's just going so much slower than the risk is increasing.
You should remember that the 1.5 centigrades target, this is not a binary target.
Yeah, of course.
It is somewhere there. You are moving into unknown space, but you really don't know exactly. And that means, even if I believe we will never reach, we cannot reach the 1.5 target now. The political situation isn't that way. We may reach 1.7, and that is better than 1.8 or 1.9, and definitely better than 2. So the probability of a dangerous situation increases rapidly somewhere beyond 1.5, but we really don't know exactly. And this is of course one of the communication problems academics have, that I think no climate scientist can say that is exactly what happens at that level of temperature increase. I think the hopeful situation is that it is still possible to struggle, if you use that word, to fight to keep temperature increases down. And every 10th of a centigrade is important. So the hopeful thing is that we now know we are on the edge of coming to a tipping point where we really don't know what happens, but we may delay it somewhat. We may reduce the probability to pass over.
The nuclear power. Why has this dinosaur of energy become such a relevant discussion?
The nuclear power argument is something which many politicians grasp for because they cannot see any other solutions which they can handle. So I think they grasp for it. But if they scrape on the surface and look into it, you will find that this is neither enough nor relevant. Let's talk a little about it. First of all, after the decade of rapid technological development, both in solar, in photovoltaics and in wind power, in fact now new wind power and even new photovoltaics can be deliver much cheaper energy than nuclear power can.
You mean photovoltaics is sun
cells?
Sun cells.
Yeah. Okay, so that is one thing. And secondly, they can be installed much faster. And thirdly, they are sustainable in a way which nuclear power is not. In fact, nuclear power is, if fossil fuel emit the emissions up in the atmosphere, nuclear power, you do it down in the earth. Right. So they are linear technologies, both of them, while wind power, not the least, and even photovoltaics, sun cells, is a sustainable technology. That is one thing. Then you have the time element. In fact, you can install wind power stations in year one, and they may deliver climate utilities in year two or something. So you can install them rapidly, and you can get energy out of it more or less immediately. New nuclear power stations will take decades to start. Look at the recent Finnish nuclear power station in Spain, which is competing with the cathedral in Barcelona to never be finished.
One is more beautiful, though. I would say.
I think the Gaudi Cathedral is more beautiful.
Yeah, perhaps. It depends on who you ask.
Okay. So that is one thing. Then there may be, I'm not the expert, there may be some future technologies of nuclear power where you can use the present waste from the present nuclear technologies and run them a second time in a nuclear power station to simplify a lot.
Right.
And then you may reduce the halving time of the waste. And I'm not against that. I think that could be a good thing. You should do a lot of research on that, and you should put a lot of efforts to stimulate academia to continue their research on this. So I think this is a potential not for handling our present climate crisis, but for handling our present waste crisis in the nuclear industry.
Right.
But that is in the future. That is in the 2050s or something, or 40s or something like that. So that has no relevance for the present climate crisis.
We've talked about reducing and reducing emissions and so on yearly. And that obviously would mean some kind of change in everybody's life.
Yeah.
Maybe big changes. It just feels so difficult.
Yes,
we fought for this. We fought to have this lifestyle, and then now we're gonna, give it away if you just are short-minded.
The whole society after the Second World War has become dependent on fossil fuels. In fact, modernity as a whole is based on increasingly using more and more fossil fuels for all we do. For our traveling, and not the least our traveling, which provides us with our freedom, so to say. Our freedom to go everywhere. Our freedom to do anything at any time and everywhere. And so that means this is the real core issue of modernity, that we are dependent on fossil fuels. And that, of course, creates the difficulties to get acceptance for a transformation. It is a complex situation that we on the one hand, must change modernity and its institutions. On the other hand, it must be done in a way that we can also change our own lifestyles. And that should be done in an acceptable way. And a problem adding to this is that you have a global inequality, makes that although all people emit. Some people emit more than others.
Yeah, exactly. A lot more than others.
Yeah, a lot more than others. Yeah. And then, of course, it is very difficult for me to convince you that you should reduce your emissions if the man over there or guy over there emits 10 times or 100 times or 1,000 times as much as you do. And this is the problem now. In fact, roughly 10% of global population emit half of all emissions. 1% emits about 20% or something.
Yeah.
So then you can always say that I will continue with my lifestyle as long as the upper class continues with their emissions.
Right.
So you have a fundamental problem. This is related then, of course, to the problem of how do you solve the global inequalities between countries, within countries. So these are the problems.
Yeah.